This is son of Tealish. Readable code is crucial, explicit and unambiguous. Static beats dynamic, verbosity too, except when it doesn't. Be pragmatic, avoid ambiguity and surprises, and embrace AVM's uniqueness.
Hello, and welcome to episode number 15 of the AwesomeAlgo podcast. Today we do have a very, very special guest. His name is Fergal Walsh. He is CTO of Tinyman and a member of a team at a company called Hippo Labs, which are the folks that are very deeply embedded into Algorand ecosystem, and they're also authors of a amazing Para wallet. And essentially today's episode is going to be structured around the discussion about a new language called Tealish, which is essentially a higher level abstraction language for transpiling very easily readable code into TEAL. And of course, as part of my due diligence, I went over numerous different materials available on Tealish, as well as Fergal's background, and would be also interesting to cover some of that. So with that, I'll give the stage to Fergal. Let's start with the biography. And I guess this is an engineering related podcast. Lots of folks here don't necessarily come from Web3 space, but most of them are familiar with computer science. So I guess the nice entry point would be talking a bit about your first domain of computer science, and what was the beginning of your journey into this very vast domain of engineering.
Okay, thanks, Al. It's great to be here on the podcast. I really enjoyed listening to the previous episodes. So it's very nice exciting to be on this side of it. I started in computer science. I've been doing a degree in computer science and software engineering. But I guess I started in computers and in programming long before that. So I knew I wanted to study computer science from about the age of 12 or 13, maybe. I put down one item on my university admissions form. There was just one thing that I wanted to do, because I've always been obsessed with just understanding how things work. And at a very early age, that just became how computers work and how software works and everything computer related. And so I got into HTML and building websites, and I think programming in Flash was probably my first actual programming language experience. And then I got into Visual Basic stuff, and which I noticed is quite common among your guests, which is interesting. It's not a language used very much at all anymore, but a certain generation of people, I think, did a lot. I ended up doing Visual Basic because I was into Lego Mindstorms, and it was a way to do more interesting stuff with Lego Mindstorms with Visual Basic. And then I started building applications and stuff. Anyway, so I realized from pretty early on I want to be a computer scientist because I want to do more. I want to do stuff with computers and software. So I studied computer science in university, and I did a bunch of courses there, obviously, and some things really interested me, like databases, like algorithms of data structure. I love those kind of things. Computer vision, machine learning, I like those in the final years. I also had courses and stuff like formal methods and compilers, and I really hated those courses. Turns out they would have been the most useful courses for what I do now, but at the time I really didn't like them. So I'm not sure that anything that I do now is influenced by what I did during those days. But I was always interested in just learning more and really trying to understand how everything works. And so we did some courses also in a very low level stuff and learned some assembly language. That turned out to be quite useful in surprising ways. And then different courses on programming paradigms, and about different kinds of languages. And that really interested me as well. And yeah, so after all the way during university, I kind of did some internships around the university as well and got into research. And I was convinced that I want to stay in academia and be a researcher.
Mm-hmm.
So I went down the path of doing a PhD. It was a bit outside of computer science. It was kind of like a multidisciplinary thing. The subject was geocomputation, which is kind of like computation applied to geo or spatial related problems.
Mm-hmm.
So during that time, I did a lot of different things. Some of it was computer vision, some of it was machine learning. There was network science, big data analysis, spatial analysis, obviously, and quite a lot of stuff. But the thing that I spent probably most of my time doing and that I enjoyed the most was actually building tools. So I built a lot of tools for doing the analysis that I wanted to do. And so I built like visualization tools and data analysis stuff. And some of it was like JavaScript-based visualization in the browser for big data sets with some kind of back-end data processing things. And so I really enjoyed that tool building part. The final year of my PhD was more about actually writing stuff, which I got into in the end, but it wasn't really what it wasn't so enjoyable. So
If
I
only there
realized
were tools like ChatGPT back then, right?
Oh yes, definitely. Yeah, could have made the whole process a lot easier. And also like what I ended up writing about at the end was rather different from what I was doing through the previous 3 years. But it was a great experience of just trying out lots of different things and kind of learning stuff at my own pace and lots of different domains. And yeah, so all in all, it was a good experience. I did a postdoc for a while after that, but then after that, I was kind of looking at, okay, what's my next thing? And I started looking at academic positions because I was always convinced I wanted to stay in academia. I want to be a teacher. Like I really enjoyed that side of things. I taught some classes. I helped out with the demonstrating side of the say algorithms and data structure or database, those kind of courses that I loved taking them. I also enjoyed teaching them, but I kind of had become disillusioned with academia at that stage. And then I found that actually I really enjoy building stuff. So why don't I just do that? And so I got a job in a travel tech company. I wasn't excited about the domain, but I was excited about it was a company that was doing Python. And I figured if they're doing Python, then it means it says something about the company itself and the team and the things that they value. And so I specifically looked for Python as opposed to, say, Java jobs.
And if I can expand on this, just because you mentioned Python, and I know that for listeners out there, Fergal do, as you can hear, based on biography, has a lot of personal, academic, professional experience with it that has been spanning for more than 10 years at this point with Python. And I wonder, what was the choice for Python specifically? Would you say that it was mainly driven by the fact that a lot of the tooling was in the domains in which you worked and did research primarily, relied a lot on frameworks that were probably best implemented or best available in Python? Like if you take machine learning, for example, right? Or like things like computer vision. I know you had a very nice project with machine learning and vision for classification of different species of animals. Yeah. And that, of course, relies on Python. Why? Because I suppose in this case, a lot of computer vision stuff is one of the best frameworks to quickly deploy something, rapidly prototype something. It's all in Python. Would you say that this was the main drive, or you also had some additional reasons for it?
It came from multiple directions. So actually during my whole undergrad, I didn't use Python at all. And I didn't really know I knew Python existed, and I knew one guy who programmed in it, and I knew it was weird because I had white space was important, and I thought that was just bizarre. But it wasn't ever part of like any course that I did, and I did a lot of web stuff on the side, but I knew PHP, so I just kept on doing PHP. I knew PHP was awful, but at the same time, I knew PHP, so I could use it to do what I wanted to do. So that was my web language, and then for the stuff that I did, like machine learning, computer vision, during my degree course, it was all MATLAB, and that was, and that's, I used it quite a bit of MATLAB, like at the start of my PhD as well. And then I think one of my colleagues recommended, like, maybe you should get into Python. Like they've good web frameworks, and also they're good for machine learning and stuff. And so I gradually started to use Python for those things. And I think one of the first projects I did, I built it, like it was some web-based tool that I was building, and I said, okay, I'm going to use Django for this. And so I learned Python in the process, and then I started using like NumPy and scikit and all of these kind of things for doing like the machine learning side of things, and then OpenCV for computer vision. And yeah, so there's a huge amount of libraries available in Python. And I quickly realized, oh, okay, I don't need any of this MATLAB thing. This is wonderful. I can just do everything in Python. And Python's a real language as opposed to MATLAB, which is just this very, very strange kind of, yeah, anyway, I never particularly enjoyed
MATLAB is
MATLAB.
Like proprietary, right? It's owned by
it's proprietary, and it's fine when you're in academia and you have the licenses available, but I don't know. It's just, yeah, I preferred the idea of something that was open source, and it was also just easier to write in Python. Like there's some things that were built into MATLAB where they weren't built into a specific library in Python, so I had to install more stuff, and it was a bit more hassle that way. But in the end, there was a lot more available for Python, and it was definitely the right choice, because then I could use the same language for everything that I was doing, and then, so that helped me in like building tools. So some of it was doing like web-based stuff, some of it was doing like networking things, and then like database access, but then also like OpenCV and NumPy and all of these together. So doing all of that within the same language was really quite beneficial. And so as soon as I started doing Python, I never went back to any other backend language. So I kind of just like got very familiar with Python and JavaScript. And so I started building tools in Python. I started building some open source projects in those. One of the things that came out of my PhD was a small framework for building web applications in Python,
Pico.
Which I kind of, Pico. So I extracted that out of the tools that I was building for research. That was interesting for a while. So yeah, I was really looking for Python based jobs. And yeah, so I ended up at that company. I worked there for a while. I became like a team lead there. And but then I heard of this company called Hippo. And so I was living in Istanbul at the time, and I heard of Hippo. They were also doing Python. They were a small company. They were a consultancy, and it just seemed to be much more interesting than where I was at. And so I started working with them, and I continued to do some like really exciting stuff related to my kind of areas of expertise, like computer vision and machine learning, while also building web applications. So it seemed like a perfect fit. So yeah, one of the examples, like you mentioned, was this image classification. So we had a project there was basically building an image classification stuff for every species of the natural world, which is no small task. So basically, like we focused on different areas of interest, but there was like plants, and then every species and subspecies of plants, and then butterflies, and all of the millions of subspecies of those, and then like other kinds of insects and things. And so trying to build up these image classifiers to enable people to catalog their collections of these things. And so we're applying, like, some of the stuff we did was like really cutting edge things. So we were applying like deep learning so some deep learning models to do some image classification, and then developing ways of searching across huge databases of images. But the novel bit was that we were trying to do this in a cost-effective way in a product. So like, it's quite easy to do these demos, but where you have like infinite resources for training and for querying of your data sets. But when you're trying to do it in a product where you're trying to optimize for the actual financial cost of it, you need to do things differently. And so there was a lot of novel research involved in that project. And so, yeah, it was extremely interesting.
Was there any overlap with stuff like semantic web, RDF, ontologies, and things like that? Because I feel like for hierarchies of like species, that could be a very useful structure of data.
I don't think there was any of that in it. No. We had some like hierarchical structures in our database, obviously, but there's multiple hierarchies of species. I learned an awful lot about the classification of the species and about the arguments in the world of like butterflies, and how different things are classified and how these change over time and how there's conflict between the different groups and things. And so there isn't just one classification system. I don't remember. I don't think there was a semantic web aspect to it. But,
just curious, yeah, because I guess the main focus was on the machine learning aspects of it.
Yeah, but again, it was machine learning to provide a feature to the users. So it wasn't like I can identify this plant with this app. It was more of it was a whole curation tool. And so we were like, Hippo was like a product consultancy, and our aim was always about building products, and we utilize interesting tech when it's useful, when it's appropriate. So it wasn't like, okay, we want to build an application of computer vision and machine learning. This is what we're going to do. It's like, okay, we have this need, we're going to apply these techniques. And I really like that approach because, yeah, that's I was kind of fed up of these examples from academia of like, oh, you can do all these fancy things, but it wasn't a real world use case. Whereas this was like, okay, this is a real product with a real client who wants to do something. And we're saying, okay, well, actually, machine learning can be used here to solve this problem for a real user needs.
Yeah, I mean, that's certainly product-oriented thinking.
Yeah,
in this regard. It's always nice
definitely.
when you have a fixed sort of constraint or environment where you can know the boundaries, but within those boundaries, you could easily innovate and try new things, basically.
Yeah, definitely.
And for the listeners out there, I will make sure to include all the links to the projects that Fergal is mentioning, as well as a few keynotes. Really recommend checking it out if you like, geocomputation and machine learning, or if you're interested in building frameworks in Python. But
yeah, so I've also I've given some PyCon talks about Pico and also about this image classification stuff, because it was all in Python, TensorFlow, and some other libraries. So it was quite Python related. So a good few years ago now, I gave a talk at one of the conferences about that.
Awesome. And so to continue on this topic, so what was the first project you worked on in the blockchain space, and how did you get involved in blockchain development in the first place, I suppose?
Yeah, so for me personally, the first project was Tinyman, which might be surprising. Wow. So Hippo as a company have been involved with Algorand for quite a while. at that stage. So like Hippo was contracted to build the Algorand mobile wallet, and so Hippo was building that with the product team at Algorand Inc. But Hippo was doing basically the design and the implementation of the Android and iOS wallets. And so in the company, there was a team dedicated to that for some years. But then the rest of the stuff that we were doing was mostly non-Algorand related. And then gradually some more projects came in related to Algorand. Like we began developing their developer portal, and then there was some backend stuff related to the wallet, like notification systems and these kind of things. So gradually more and more Algorand, the word Algorand was coming up more and more in Hippo. But I wasn't directly involved in any of these projects. And I knew Algorand was some kind of blockchain and crypto thing, and that was about all I knew. And to be honest, that was all I wanted to know. At that point, I was definitely a crypto skeptic, and so like I had heard about Bitcoin back in say 2009 or 2010, and at first I read about it and I thought, okay, this is interesting. Like this is like permissionless money, decentralized money. But then I read about the proof of work thing, and I lost interest. I was like, this is just a huge waste, like so much waste of resources, and it's only going to get harder and harder as time goes on. Like this makes no sense. I like the concept, but I was like, no, I was put off by that. And I assumed that everyone else in the world was going to be put off by that, and that this thing will never take off. And so I kind of heard some things about Ethereum and things later, but it's kind of more the same thing. And so I never believed in it. But then, how do I end up working for Tinyman? So yeah, Hippo as a whole got more and more involved with Algorand related things, and some people in Hippo were much more enthusiastic about crypto than I was. And so they were like interested in this DeFi space. And so Khan, one of the partners at Hippo and the CEO of Tinyman, so he was very into DeFi and on Ethereum, and he was involved like quite a lot in the Algorand related projects and talking to Algorand people quite a bit. And then he was saying like, okay, you're saying Algorand is awesome. It's extremely fast. It's very cheap. It has like instant finality, like all of these things that we don't have on Ethereum, and it's environmentally friendly, but it doesn't have any DeFi. It doesn't have a DEX. It doesn't have any of these things. And so he started like asking the team, well, what would it take to build? What would it take to build something for Algorand? Like, could we build a DEX on Algorand? And so that idea kind of took legs, and then I was roped into the project, and I was kind of convinced that this was something that was worthwhile looking at. They gave me the brief like spiel about Algorand and said, okay, this is environmentally friendly, but it does all these other things. It actually looks pretty interesting. I said, okay, I'll look into it. And then I kind of took a deep dive into it, and just tried to read up as much as possible about Algorand itself, and then going back to reading up on Ethereum and like understanding why Ethereum exists, why this DeFi space exists, what it's all about. And then so kind of switching between like the technical side of Algorand, the philosophical side of this whole space. And then I gradually got more and more interested and excited about it. And as I read more about Algorand, I was like, okay, yes, if we look at this blockchain space, this is clearly the right way to do it. Like they've solved a lot of problems. There's clearly problems with other systems, but they seem to have thought of everything here. And there is some kind of like capabilities on the blockchain, it seems like we could build something. So yeah, we got some assistance from Algorand Inc. to actually design the first version of Tinyman, and they kind of wrote up like a design document as an exercise to figure out, okay, what does Algorand have now? Does it have the capabilities needed to build something real on the network? Can we build DeFi on Algorand? What is missing?
Which year was this? Just curious, because it tells a lot about the state of the tooling. And I'm sure
so this would have been the this was the very start of 2021.
I see.
So I guess this idea had kind of started sometime in like late 2020, and then I remember that I kind of started full time on that project, fully in the research phase in like January 21, which seems like a very long time ago, but it's not. It's just over 2 years ago. And yeah, so I remember like reading through that design document, and there was all like so many keywords that I just did not understand and know what was going on. I remember this discussion of the minimum balance requirement and these like calculations in there. I was like, how on earth, like, what is this? Like, so I would go through this cycle of reading the document and then going back to research, reading the fairly limited developer portal docs at the time, and then gradually grasping some topics and then experimenting with some stuff, like through the SDKs and then with TEAL as well, and then kind of reading the docs again until I got to the point where I was like, okay, I understand what this is doing, and also I know what bits we want to change. I know what other features we want to implement, and I have some ideas about how we would do that. And so that was quite a gradual process, but eventually I got to the point where it was like, okay, yes, I know what's going on here. But yeah, I realized that, okay, I guess now we're getting into the programming part of actually building something on Algorand. And so I saw there was this TEAL thing. I saw there was TEAL and Pyteal, and I looked at Pyteal, and then I saw, okay, this is Python for building up TEAL. I really need to understand the TEAL anyway, so I'm going to go into this. And I wasn't in any hurry at that time, so I kind of just took my time to learn the TEAL, and I realized, okay, this is assembly language. I've done this before. I know what I'm doing. And I remembered that in university, when I was learning assembly language, I built like a simulator in JavaScript to actually be able to visualize like the stack and the what's going on as you go through each line of the assembly. And so I did the same thing for TEAL to basically figure out how does a TEAL program actually run.
Is this the TEAL debugger that's available in the repo?
No. That's something much more recent.
I see.
This was, I don't even remember what it was called, but it was something that I was using it for a while, and I was using it to basically debug like test programs that I was writing. But it was a re-implementation of the AVM. But at that time, that was very easy because the AVM wasn't called the AVM, and it had extremely limited functionality. I think it was even, there was, I was going to say before stateful contracts, but that's not true. There were stateful, but even just focusing on the stateless part of it, just to understand the programming concept for that. And so I realized, okay, this TEAL thing, it looks crazy, but it's actually quite, once you get over the whole stack-based language thing, it's quite useful and readable, and it's not as low level as it looks. Like there's these very high level stuff available as opcodes. And so, yeah, we did start off building Tinyman in Pyteal. Still, we figured that was the way to go, and some of the example code that we had was written starting in Pyteal, and we went that way for a while. But in the end, I kept having to come back to the TEAL and debugging the TEAL. And when I was trying to figure out what was going on, it was always looking at the TEAL code. And then I said, okay, this Pyteal is just getting in the way. I'm going to take what the TEAL that's generated from the Pyteal and freeze that, and then get rid of the Pyteal and just say, okay, now this is my source code. And then comment all of the TEAL itself and then iterate on that. And so I did that because I needed to debug and I needed to understand the TEAL code, and just being able to go from the error message to a line of TEAL was much easier. And also because at the time, the resource constraints on Algorand were very low, and we needed to really optimize every single byte of code. And so there was some stuff the Pyteal was doing that just wasn't optimal. And so I needed to do it really at the TEAL level. And so, yeah, Tinyman V1, we built it with TEAL. And at the time, I thought that was a reasonable experience. I thought that it worked. The code worked. And I thought, yeah, okay, this is like writing contracts is hard. It should be hard. This is serious stuff. Performance is important. It's reasonable that we need to write at this low level. But yeah, I mentioned this during the cipher that I kind of convinced myself that this is the way it should be. But after reflecting on it afterwards, I realized that was insane. Like there's no way that it should be that hard. Why should it be that hard to write something that is performant? If we're writing something that is like a critical application, it's a deploy once, you can never change it. It's going to handle millions of dollars worth of funds. Surely we want the thing to be as easy to read as possible, not something that is extremely opaque and takes a huge amount of effort to read. So that was one of the things that I realized when I was writing, that I was trying to implement something relatively simple. I would put huge amount of mental effort into it, because you need to load up the whole program into your head, keep it in your head, and then manipulate the stack in your head as you're reading through line by line. And it was exhausting. And so I figured there has to be a better way to do this. And then I kept going back to Pyteal and going, like, maybe I should be doing Pyteal. Maybe that is the better way. But every time I looked at it, I was just put off by, okay, the things that I know how to do these things in TEAL, but for some reason they're different in Pyteal. And I know Python like inside out, but I want to do an if statement, and you're telling me to do this crazy thing that looks like I'm writing jQuery in JavaScript. I found that just really confusing. Like it was Pyteal, but
it's like you have to like keep two different programming languages in your head, but you're playing by the rules of Python at the same time. Basically.
Yeah, I would say three programming languages, like TEAL, Python, and Pyteal. Like Pyteal itself has its own language, basically. And so I found myself often getting confused. Like even after working on it for like weeks at a time, I would still get confused about which bits were executing at the Python, at the compile time versus the run time. And yeah, so there was just many aspects that just put me off the Pyteal thing. And I said, like, but why does it have to be this way? Like, why can't we have a real language that compiles down to this TEAL bytecode? Like, surely there's nothing fundamental that's stopping us from doing that. Surely we can have something that is where we can still write efficiently, but in a standard like procedural style, not in this stack-based assembly kind of style. And so I started thinking about different syntaxes for writing TEAL. And I would take the TEAL code for Tinyman and then start rewriting it in different kinds of procedural syntaxes to see what would work. And so I looked back for this a few months ago, and the first reference to Tealish on my computer is actually from August 21. So this is before we even went to mainnet on Tinyman on V1.
It's been incubating for quite some time then.
So yeah, so basically like since the first days that I started writing TEAL, I was like, okay, there has to be a better way of doing this. But it was in the back of my mind. And then I think like on some flight to somewhere, I started just thinking about how could I like what is the language that I want? And so I had
I'm sorry, in between this, have you considered looking at programming languages for smart contracts in other ecosystems during any of these, or all of this was basically you focusing deeply on the things available within the Algorand ecosystem, basically?
So it was mostly based on what was available within Algorand. I was reading quite a bit of Solidity because like Tinyman was based directly off Uniswap v2, which is written in Solidity. So I was regularly going back to the Solidity code to look at like the calculations and things there. And so I hadn't written any Solidity, but I had a good feeling for at least how to read some parts of it. And then I was regularly reading like blogs and Twitter threads about exploits of contracts on Ethereum and in Solidity, and kind of the horror stories of the different things that can go wrong. And I just found that very interesting to kind of understand that. And so these things were in my mind as I was thinking about TEAL and a higher level language for TEAL. And I was kind of also drawing on my previous experiences of programming languages. And so like MATLAB, for example, I gave as an example. So like it's kind of a language, but it's not, I would consider it not a real language, because there's some stuff that you just expect to work in a particular way and it just doesn't work. It like the syntax does it, the parser doesn't allow it, and it's very confusing. Or like I had done a bit of micro program for microcontrollers. And so I'd use MicroPython, and I had the experience of working in something that is Python, but not quite Python. And I had the experience of what that felt like, and of understanding this, realizing this disconnect that occurs when you think that you're programming in one language, but then you get these unexpected errors. And so pretty early on, I was convinced that like, no, we don't need to compile a real current existing language down to the AVM. We need a language that is unique to the AVM. And in a way, I was like telling myself, no, that's absolutely ridiculous. We have literally thousands of programming languages in the world. How could we possibly need another one? But the AVM is a unique runtime environment. There's no reason why Python or C or Solidity or anything else or JavaScript or whatever why it would be good to compile those to run on the AVM. And so I was convinced that just some kind of better syntax around what TEAL offers was the way to go. So taking advantage of everything that the AVM has and all of the opcodes that exist, not trying to impose any other kind of assumptions from other runtimes on it, but just doing something that's a bit more familiar to programmers who are experienced in other languages, but also different enough that their mind knows what language they're programming in. So I think that's like, there's a reason why we have all these different syntaxes in programming languages. Like some use curly braces, some use like semantic white space. Some have this kind of block-based start and end kind of thing. And there's all these different things, but it's actually useful that we have these different syntaxes rather than everything being a curly-based language, because it helps our minds to basically load up the right parser and to understand the context that we are working in. So I purposely want, like, the earliest version of Tealish that I have on my computer still, like, I had curly braces, and it was a curly brace language for some reason. And at some point I switched that, but I consciously wanted it to not look like a standard curly brace language, not look like Python. So yes, there's some things that are Python-ish in it, but at the same time, it's very clearly not Python either. And just so that it's very obvious to the reader that, like, this is Tealish that you have in your mind right now as you're reading through these. So Tealish semantics apply, not Python semantics. So there was all these kind of things going on in my mind that, like, led to the design of it. But most of it just stayed in my mind for many months. Occasionally I would do these, like, rewrites of Tinyman contracts and some other contracts that I've been working on or thinking about, just to experiment with syntax, but I never started building a compiler. Until we started talking about Tinyman v2. And then I kind of surveyed the ecosystem again and said, okay, yes, I want to build Tinyman v2, but I'm scared. Like, I don't want to do it with the current tools we have. I don't want to go through the exhaustion of writing in TEAL again. I want to be able to collaborate with my colleagues much more on this version of it. I want something that's really readable to the auditors and obvious what it's doing. We want something that, like, the users of our protocol can actually read and understand. Like, if they're technical users, they should understand, and they should be able to look at, like, the formulas involved and the different steps that are involved in the protocol. And, like, we'd be kidding ourselves if we said that they could do that with Tinyman v1. So I wanted that, and my colleagues, like, agreed that we needed something better than that. And so I kind of, we continued talking about, anyway, what high-level features we wanted in the protocol and stuff. And at the same time, I started playing with, could I make a compiler to compile this idea of a language that I have? And I assumed that it would be very difficult, but in the end, I made some progress pretty quickly, and I got excited about building it. And I figured that even if in the end we write TEAL, that if we can write, like, some kind of pseudocode in this language and have some kind of check, some kind of compiler thing, it can still help us. So I had that, like, in my mind, that whatever we build, we should be outputting TEAL, like, not AVM bytecode, but actually TEAL. So TEAL that is still readable, TEAL that's still auditable. So we wouldn't expect, like, okay, all of our core code that we write is going to need to be auditable. So we shouldn't expect that our auditors are going to read and audit a brand new language. It should be so the TEAL that is output should. So basically, unlike Pyteal, the TEAL that is output should be nicely commented, nicely indented, basically map back easily to the source code, so that you could read through that TEAL if you're an experienced TEAL reader and properly understand what the intent of the authors was.
I think some auditors should pay Hippolab some royalties, because I think with Tealish, certainly are gonna, make some of their lives a bit easier in this regard.
Yeah, definitely. And so, like, skipping ahead, we did write. Obviously, we wrote the contracts in Tealish, and Tealish became a thing. We wrote the contracts in it. We kept on iterating on the language as we developed the V2 contracts, and then we came to the auditors and said, "Look, okay, this is our source code. It's in Tealish. It's this new language, but here's our TEAL. You can audit this." And they said, "Okay, yes, we'll definitely audit the TEAL because we don't know what Tealish is." So that's fine. That's what we expect. But then after, like, each week as we met with them, they said, "Actually, we're still focusing on the Tealish because it's a good description of the business logic. So we don't need to rewrite a pseudocode version of what you're doing. We're reading from the Tealish, and actually it's quite readable. and we can understand your intentions. So we don't need to look at the TEAL yet. And it went on like that for quite a while, and they did the vast majority of their analysis at the Tealish level because it made their job an awful lot easier. But then after they'd finished all their semantic analysis of the protocol and what it's doing, then they went through the TEAL line by line and said, okay, is this really doing what the Tealish code says it's doing? And so they didn't audit the Tealish compiler, but they audited the output of Tealish. And they said that like that process was also very easy to do because it was very systematically generated TEAL. And it included all the original comments and basically all our intent of what we were trying to do. And so for us, that was a huge, it was a huge win because we paid them to do for some length of time to analyze our contracts. They went much deeper than they were expecting to be able to go because they were analyzing Tealish code and they could cut out some of the steps from their analysis. They were able to much more easily understand what we were trying to do. So then they could spend more time on doing some more advanced modeling of what we were doing. So that basically added to our confidence about the protocol itself. And then obviously it was a good, it showed to us that, okay, Tealish did its job. It was readable to somebody who had basically the README of the repository to look at in terms of this is what Tealish does, but no, most of the documentation that exists today didn't exist then. So, but still, it was obvious to them what it was doing, and it wasn't surprising. There wasn't any, there weren't weird syntax things that they couldn't get their head around or anything that just put them off from the start. So that kind of told us that, okay, we did something right in the design of this. And so then, it kind of gave us the encouragement to continue with the project and try to say, okay, let's really push this as a language for Algorand. This should be more, because as we were we developed Tealish as part of our V2 work package. So in order to build our V2, we built Tealish, and we kind of built them somewhat in tandem. But as a whole thing, if we put the two projects together, that's a reasonable time spent just to build our V2 protocol.
It's kind of ironic that it also sort of mirrors the way TEAL requirements were constructed and how TEAL was built in the first place. It was also a very, very specific set of requirements that were optimizing for, performance, efficiency, and, the team really had to focus on things that, are available here and now. In this case, it's also amazing to hear that, you had a very specific goal to solve with this. You had Tinyman V2, and Tealish wasn't just a way of, reflecting on what's possible at the moment in regards to proposing an alternative to things like Beaker, Pyteal, but it was actually trying to, push towards, I would say, towards a very unique direction in regards to how TEAL itself, or experience with TEAL contract building, could be improved. And it's very interesting to see how you guys approached it.
Yeah, so we were focusing on a very solid use case. And so that directed the features that we focused on implementing first. But at the same time, there was a bunch of other use cases that I kept in my mind, because I wanted to make sure that we weren't going into some local minimum with the optimization of Tealish. It shouldn't be something so constrained to how Tinyman works. It should be a relatively general Algorand language, but at the same time with a real world use case in mind in its development. But so there was a few other projects that I was thinking about at the time, so I was writing some parts of those contracts in Tealish as we went along, just to make sure that it was staying general to general problems, and some features that were much more involved that we considered included in V2, but in the end we didn't. But they would have involved we had some ideas around stuff that might have used box storage and then have structured data. And so that led to the ideas about, okay, having structs in the language and basically structured access to byte arrays and all this kind of stuff. Then I started thinking in detail about boxes are coming. Okay. We briefly thought about, we might use those in V2. Then we said, okay, no, we're going to limit the scope of V2. But I still was able to think about, I had a solid use case of a protocol that would use boxes. And so I would think, okay, what would boxes look like in Tealish? And so we had like an implementation of boxes in Tealish before they even were in Pyteal. We continued basically to try to develop the language based on real needs, like rather than trying to design it around some kind of toy contracts or like potential possible use cases. It was mostly designed around our own experiences at the time, and then hoping that would generalize.
And then I guess another nice feature to highlight is sort of the interoperability with changes in the TEAL, right? Like Tealish, the way Tealish is designed, it's taking this sort of abstraction layer very seriously. So there's changes in TEAL in the future. It's not something that could directly break Tealish at all. It's pretty much the matter of, then later adding additional, I suppose, primitives for the compiler so that these features are going to be available. But that particular aspect of the fact that Tealish is pretty much, you could think of it as sort of a sticker on top of TEAL, right? Like it doesn't really, you don't need to peel the sticker off every time TEAL changes. Like it's pretty much there. And then, you slightly update the sticker itself at some point, and here you go, you have latest support for it, essentially.
Yeah. So I don't remember when like that design decision came in, but it was pretty early on, and it was driven by two things. One was that I had seen other like attempts at languages for the AVM, and I had seen how they go stale and they go out of date because they were built for like AVM what,
press,
3 or
press
4
F to pay respects to, because I do have a list of all of those things on the AwesomeAlgo repo.
Okay.
And I've been seeing people opening those things every time, like every couple of quarters, and then they slowly go stale, and it's very sad to see it because it's also different people's different initiatives. But
so like obviously, like I was not the first person to think that there could be something better than TEAL or than Pyteal, some alternative way of writing these things. But usually like these projects, they run out of steam, or the developer loses interest or whatever. And even projects like that we see where there is a significant development team behind them, but it takes them some time to catch up to the AVM. And I didn't want that. Like I wanted something that, like, okay, some new feature of the AVM is coming out next week. I want to be able to experiment with that from Tealish immediately. I don't want to have to do extra work to implement the features to support that. And I don't want the users of Tealish to have to wait for me or some other contributor to implement those things. And so I figured out that there was this thing in the Algorand repo called the linespec.json. And I saw that it was being used by Pyteal in some way. And it describes every opcode that exists on Algorand. And linespec.json is like generated from some other file, which also generates the documentation that you see on the dev portal. But it basically completely describes, or nearly completely describes, all of the opcodes of the AVM. And I thought this was fantastic. This is a machine readable way to know the details of every opcode that exists. So not just know the names of the opcodes, but know the arguments that they take and know what they return. And so
pretty much Swagger for EVM, I guess.
Yeah, basically. And there was an issue about removing the linespec.json from Go Algorand a few months back. And thankfully I noticed it. And I was able to comment on it, say like, please don't remove this. Like, I'm using this. I have a project. This is pretty much fundamental to how it works. So just letting you know it's there, and don't remove it. Like, feel free to change it. Just let me know. It would be awesome if you improved it to do a few things, but just so you know, I am currently relying on it. And so that was before we had done any kind of public announcement of of the Tealish project. But it was good that I got in there and let them know that I'm using it. And then recently, Ben or Barnji from Discord has been helping a lot on Tealish, and he saw that I was using the line spec and that this was kind of fundamental to how Tealish works. And then he saw that, wait, there's loads of information that's missing from it. So he went and spent quite a bit of time on actually improving the line spec and adding a lot more semantic information to it. So now that's going to help Tealish even more. So the compiler can basically become smarter, but just by consuming more information from the line spec. And yeah, so the most important thing about that line spec is that from the Tealish tools, you can basically pull in a new version of the line spec directly from Algorand GitHub. And then the Tealish compiler knows about new opcodes. And so when boxes came out, or when boxes were in development, I was able to experiment with the box-related opcodes by just pointing at the feature branch on Algorand and use like the box put, box get, etc. And then any other user of Tealish at the time, if there had been any, would have been able to do the same thing without requiring any new release of Tealish. But then there will always be times when we say, okay, there are some things we want to special case in the language. So for example, we created a slightly higher level interface to boxes in Tealish. And so you can still use the opcodes directly, but there is a slightly higher level interface, which makes things a little bit easier. And so that's something that's built into the language itself. But then whatever the next features that are added to the AVM, they'll just be directly available because of the magic of that line spec. So that was, I think that was a really important discovery. It was nice that that thing existed. And because if I had to request it, it's unlikely that people would have gone to the bother of building such a thing. But the fact that it already existed meant that I could really rely on that. And so it means that Tealish is kind of self-updating for quite a while. There will be stuff like that. It will be nice to have a language native interface for, like for example, inner transactions. So we do some special syntax for inner transactions just to make them much more readable in Tealish. So in the future, if there's something like that comes along, then after some time we will likely add some higher level syntax for those. But we try to keep it to a minimum so that most of it is driven, basically dynamically discovered and driven from that line spec.
I think what might also be, I guess, useful for your case, and I'll make sure to contribute that once I get some time, is a very tiny cron-triggered listener somewhere on the Tealish repo that will just run, let's say, every 2 days, every 3 days, and check if there's any changes in the lang spec on the Algorand repo. And if yes, it will either open an issue or it will open like a PR saying, okay, here's a new lang spec that came in. It's time for a little boost to Tealish. I think that might be
that would be amazing. Yes,
because I only realized after talking to you right now, like how important the lang spec is to this capability to have sort of an abstract layer there. So like I'm very invested into Tealish. I think this is an amazing language. Not sure if you can call it like a pure language, as you said, but like I guess a transpilation language would be something a bit closer to it. But from my side, I'm also very keen to see how it evolves, and would love to add some additional contributions there, basically.
Yeah, no, it'd be great. It'd be great to get there has been some external contributions already, and as I said, Barnji has been doing quite a bit of stuff. At the moment, we're like refactoring a lot of internal stuff, and for quite a while, I've been working on like types in Tealish. So basically supporting higher level types. So something other than just basic int uint64s and byte strings. So basically like bytes of specific length and like a uint8, uint16, those kind of things. And these are very relevant for when you're storing data. So if you want to put stuff into a struct, then you want to have, if you can specify that the integer that you're going to store is only 8 bits rather than the usual 64-bit, it makes a big difference in terms of space usage. So we're doing quite a bit of work on that at the moment. You're just trying to find the right interface for that, the right syntax, the right semantics, keeping it true to the philosophy of Tealish, keeping it as close to TEAL as possible, keeping it understandable for the user. So we're taking our time with it rather than rushing into choosing any specific
of course.
syntax. And then there's also like arrays, and that's very linked to types. But basically, yeah, you can treat a byte string as an array of integers or various other things. So yeah, they're definitely they're kind of works in progress at the moment.
And maybe to slightly expand on this, because for the purpose of initial intent was to cover a bit on the like sort of main features and programming contracts, but I realized that I think the best way to learn about this is actually your keynote from Decipher, because this is where you really go deep into very individual, like every specific capability of Tealish that's currently available. So for that particular question, I will actually recommend our listeners to check that one out first, because I think that's a perfect overview of individual programming constructs in there. But within the scope of the podcast, I think, also to be mindful of your time, of course, I guess it's an opportunity to ask a bit more deeper and interesting questions in this regard. So if you don't mind, in regards to constructs, I just have one additional question, specifically about inline TEAL. Like I wonder what was the sort of the reasoning, the motivation behind there. Is it essentially did you stumble upon certain cases during implementation when raw TEAL was basically something that would benefit the implementation, given, I don't know, a certain use case for the program, or like what was the story behind support for inner TEAL, basically?
So in Tealish we have this TEAL block, and within that you can put whatever TEAL you want, and it stays as TEAL, and you write normal stack-based TEAL. I think it was mostly driven by this idea that whenever you create an abstraction, you should create an ability to break out of the abstraction, because no abstraction can be perfect. And so, yes, like when you break out, you lose some things. And so obviously the compiler just says, okay, you're on your own there. Like, I do not know what's going on inside that block. But sometimes you need to say to the compiler, like, trust me, I know what I'm doing, but I want to write it this way. And so I imagined that there was going to be cases where, like, you do something very stack optimized. So, like, rather than, so in Tealish, like when you assign stuff to variables, then they get put into scratch space, and then so they're stored and they're loaded, and it's not necessarily exactly how you'd write it if you were writing TEAL, especially as an experienced TEAL programmer. Like somebody who's used to optimizing their programs in TEAL would try to make use of the stack as much as possible. And so they'll do a lot of stack manipulation in terms of swapping and duplicating and digging stuff out of the stack, and basically using as few opcodes as possible to achieve what they want to do. So I knew that for some mathematical stuff that was going to be needed. And in Tinyman v2 we didn't use that. And I mean, I would hope that it's going to be rarely needed, and I would hope that when people use it, they would package it up inside a function, so that at least their programs remain readable. And but I think there will be some use cases where you have some function, and then inside the definition of the function is just some inline TEAL. But yeah, you can think of it definitely as a feature for advanced users.
And I guess like the way I may like put up how Tealish, because like I'm sure a lot of listeners here at this point are very interested to learn more about Tealish, and I'm sure most of them will be jumping towards a specific keynote on this. But in short, if we were to answer the question, like, okay, we were talking about Tealish, right? It makes TEAL readable, but how does it make TEAL readable? And I guess the easiest way to describe it is basically, well, TEAL is, as you said, right? It's closer to machine code. It's assembly-like. So I'd say the main innovation here, and not to discard, the work and effort that folks at labs, at Foundation are putting into it, with Beaker and Pyteal and things like that. But I guess the most important aspect is that you somehow managed to basically turn TEAL into an imperative language without losing much of clarity in the implementation, and all of that is pretty much, I think we haven't mentioned, right? But I think it was pretty obvious based on your experience that the implementation done is in Python, right? The compiler is done in Python.
Yeah.
For Tealish, but I guess this is like the single most important part, at least in my opinion, for people who are going to be building on this, is that finally you can deal with TEAL without a lot of abstractions on top of it, and essentially talk with it as an imperative language. Yeah.
So, I mean, the way I think I like talked about this before, where to me, like learning TEAL should equate to learning the AVM and vice versa. So if you're going to program for the AVM, you need to understand the AVM. You need to understand how contracts are run, and you need to understand all the opcodes that are available. You need to understand that there is scratch space, and there is the stack, and there's local storage, and there's box storage, and all of these kind of things. And then you're going to program in it. So the language that you're using should use that knowledge that you have of the AVM. And as you read more examples of other programs written in Tealish, you should discover more features of the AVM that maybe you didn't know about. But by reading the Tealish, you will discover a feature of the AVM, not a feature of Tealish. And so I wanted there to be like a very one-to-one mapping, very little, like in a way, very little abstraction, but just kind of a reformatting of the TEAL to make it in that imperative style that we are used to, so that our brains have to do less work in order to read and write code. I think that's the key to a readable language, just putting it out on the page, on the screen in front of you, and making it accessible for our brains to parse in the way that they're used to parsing things.
I'm sure there's at least one functional programmer listening to this who's a bit disappointed by this answer, but
yes. I mean, yeah. So there is I also possibly, well, in my mind, I have this idea that maybe the best language for Algorand or for the AVM might be a Lisp-like language. I believe that when we had just logic sigs, I'm not so sure when we have stateful stuff with side effects and things, but logic sigs, they seem to lend very nicely to this Lisp-based thing. But at the same time, I really enjoyed learning Lisp in university and playing with it. For a while, I was convinced that this is how all the programmers, students should learn how to program. But the reality is that most people are better trained at reading and writing imperative style programs.
Yeah, I mean, we're talking about generations of people, pretty much.
Yeah.
Ever since, the C boom, I suppose, in this case. It's And
Yeah,
talking
and
about
so
adoption in this case as well, like it's
adoption
makes
is
sense. So.
important. Other people, like, I think readability of contracts is like so important, like more than any other programs in any other domain. Like the whole purpose of this thing is that our contracts are readable and transparent. And so we should be aiming for languages that are optimized for readability. And that means like the common denominator among all potential readers of contracts. So something that is going to be relatively familiar to them. Like, yeah, Tealish it's a fairly boring language. Like as languages go, there's
And
nothing
it should be,
interesting.
right?
Yeah, and that's what it should be. Like it's it could be exciting, like to develop a language that has all these fancy, exciting features. It could be exciting to play with that, but it's not what we should be using to develop like immutable contracts that are going to live on the blockchain forever and be the future of finance and the future of other decentralized important systems.
And like I guess it depends on how you look at the term boring, because like from my side, I might actually find this quite exciting. Like, and I think I finally understand a lot about like your mindset in regards to how you build this, coming from this very interesting academic background, but like eventually sort of morphing towards more product-oriented approaches. And like one thing with Python specifically, at least for me, is like like a lot of people do front end, for example, and hate back end because they say, okay, I want to write code and I want to see immediately the changes that are being applied. I want to make a button. I want to see that button, right? I don't want to wait 10 hours until all my Docker Compose images are going to load up so that I can see this button being rendered. And like for me initially, like Python was that taking that fun interactive aspect of doing something, implementing something rapidly, quickly, and seeing the results quickly without dealing with the mess of the web developments that it is today. And now for people who are experienced with smart contracts in Algorand, Tealish is basically, at least in my opinion, is something that also takes this fun experience with seeing and iterating more rapidly in this regard. Of course, it needs to be clear. It needs to be precise. There needs to be audits for that as well. But the speed at which you are able to iterate it is also something very exciting. And I think, I know we are going a little bit over time here, but just wanted to, because this leads me to another question that I wanted to just have a brief of backstory for it. But Tealish has a very, very useful companion named AlgoJig. And I was curious, on what's the backstory there. Was it also something that was part of Tealish, and now we know that it's actually been quite a while, like being developed since 2021. So I wonder if it's something that you used then to solve the aspects of the testing of Tealish.
So AlgoJig is. And I will come back to the fun and the boring part actually, because it's very related actually to this. So AlgoJig is a tool for running contract code and running transactions against a known state of the blockchain. And the state of the blockchain you can define programmatically through a Python interface, but the transactions and so the contracts themselves are executed in the 100% real AVM itself, the block evaluator that evaluates everything. And in the end, it outputs a block or fails and tells you where it fails, etc. And it's kind of like the dry run endpoint that exists on Algorand that you can use for testing contracts, except that it works for transaction groups. But it has the capability that you can set the initial state, like dry run, which is unlike the new simulate endpoint, which is coming, which is kind of like dry run because it works across transaction groups, but it uses the current state of the blockchain. So it runs your transactions against the current state, but doesn't commit them. So it tells you what the output would have been, the errors or the successful results. So AlgoJig is slightly different in that it doesn't run across the current state of the blockchain. It runs across a made up state. And so we basically like force some data into the blockchain. So inside AlgoJig, there is no history of the blockchain. So we give it a history, and that history we can invent. So if we say this account has X amount of algo, it just has that amount of algo. It doesn't have a history to get to that point. It's just this is the current state. And so that allows us to quickly set up tests and scenarios for things that might otherwise be difficult to get into that point of testing, or some kind of scenario that involves some local or global state and timestamps and stuff. And if you want to run transactions to get to the point where you want to test a specific edge case, you would need to be executing transactions for years. And with AlgoJig, we can just programmatically say, this is the state. What would happen if we run these transactions against it? And so why did I build this? Basically out of massive frustration. So every time that I wrote contracts on Algorand, I developed a new testing suite for them, trying all sorts of different things. I guess the first contracts that we wrote were, testing against a node, like in a private network, and where we would have to initialize some accounts, fund them from some kind of dispenser accounts, create some assets, create some pools, and go through this process. And this was before Sandbox. And then Sandbox came along, which made that setup a little bit easier locally. And then Sandbox Dev Mode came along, which made it a little bit easier again, because you could speed up the block times. But it was an extremely frustrating process to set up the thing that you want to test. And so I started looking into how the Algorand team tests the AVM itself and how they test TEAL. And I found these tests inside the Go Algorand repo where they are actually executing TEAL against a test ledger. And so the ledger being the core part of the Algorand blockchain, in a node, there's this ledger kind of interface. And so there's a test ledger or a debug ledger, I forget whichever it was called. But it allowed you to do some things like setting some state, setting some account balances, and then executing a transaction against those, or executing a contract in the context of this ledger. And so I use this to write tests for Tinyman v1, and basically all of our tests were written against this thing, but they were written in Go, and they were written inside the Go Algorand repository, because some of this was private. They were private stuff in Go, and you just, like, it's not Python. If Go says if it's private, it's private. So I was able to write some tests, and it was much more performant than the previous tests that we had, that were interacting with a node, and I could iterate on many different scenarios, and it worked. But those tests at some point became, I couldn't update them because the internals had changed. And all right, I could update them, but there would be a lot of effort to update them because the internals of the ledger had changed, and obviously it was private code, so there's no reason why that's allowed to happen. And also, this is not really a approach that I could recommend to others. Oh yeah, just write your test inside like a fork of Go Algorand, and no, it wasn't really practical. So, but I thought about that approach a bit more, and I always wanted to just write my test against the real Go Algorand code, the real full block evaluator. And so I started digging into the block evaluator, seeing how it works, seeing what kind of public methods it has. And of course, it doesn't have anything that's not designed to be used in production. So there's no such thing on the real ledger inside there that says set account balance to X amount, because that's not something you can do on the production version. So I figured that, okay, I need to get this ledger into a state that I want. And so I realized, well, okay, the node reads everything. It reads its state from a database, like an SQLite database. That's what the node is. So I can just modify that database and give it a history, pretend that it has a state that is this, and the node is just going to read that and say, okay, that's my current state. It's not going to check all of the blocks up until that point to see how it got to that state. It just says, that's my state. And so I figured, okay, we'll modify the database, put the state we want in there, and then evaluate the transactions against that. And so we were able to package that whole thing into a little Go binary that just reads and writes to a database. The database writing is done from Python. The passing the transactions is done through a sub process. So there's no network involved. There's no Docker container. There's no anything. It's just a small binary that we are interacting with through Python. And so then the Python bit allows us to iterate quickly, writing tests, and using our standard testing tools that we're used to, like the standard Python unit test and other test runners and stuff, while setting like the exact scenarios that we wanted, without the boilerplate of like issuing transactions to get into the state that we want.
I think the fact
so
that it runs offline is amazing. It's about one of the
like it's 100% offline. So I don't need to, when I run my tests, I don't need to say, oh, I need to like bring this Docker container up first, or I need to start the service to start the node or something like this. It's just like it's as if it's some Python code that just runs. And so that just allowed us to write tests, like loads of tests for Tinyman v2. So again, this was all built as the Tinyman v2 package. We need tests, we need robust tests, we need tests that are readable, we need tests that are going to run fast, we need to like writing tests. So we need this thing. But it also brings the fun back into writing contracts. So that's so it's Algo jig because it's a testing jig. It's a thing that holds some components in place while we modify some other parts of it. And so one of the things that I do when I'm writing Tealish locally, I have a small little script, which is just called run.py, which has a basic jig for Algo jig and running my Tealish program. So I give it a Tealish program on the command line, and I give it some arguments I'm going to pass in as arguments to the contract. And I have a basic application call there. And then I can write like testing.tl. That's a standard file that I have opened on my computer. And whenever I want to test something in Tealish, I just write it in there, and to see what the results would be, I log the output. I have some utilities for decoding those outputs if they're integers or stuff like that. But once I started doing that, and by the way, this also works like with TEAL. So there's no reason it's not specifically related to Tealish. It also it works with TEAL the same way. But if you use Tealish, you get tracebacks or like errors relating back to the Tealish line numbers, which is nice. But yeah, this totally changed the way that I approach, and for my colleagues, the way that we approach writing contracts, because we have somewhere which is nearly the equivalent of like the IPython console, where you just write some code and you see the result. You have that immediate like feedback loop. You don't deploy some app, you don't fund some things, you just write some code and then you see the results and you iterate on, you get the errors, you iterate, and it's that immediacy of it, I guess, that like what you were talking about when you deploy some code and the front end thing. And so it's, that immediacy of being able to write contract code and just very quickly understand what you're doing. And then, so I found that once we had these tools, like the combination of Tealish and AlgoJig, even in their very early versions, we were able to like iterate on ideas for the contracts and experiment with stuff in ways that like we couldn't imagine doing before. And it was fun because we'd implement some formulas or calculations or some state management thing that we had an idea about. And we just try it out and see if it works, and share ideas about it. And so that's what development needs to be, and that was what was missing for us before on Algorand. Like, it was such a slow feedback loop.
I feel like if there was like some sort of mental map of a testing pyramid for Algorand smart contracts, and if we like start from the top, AlgoJig and Tealish, I feel like really lies down there, like at the bottom in regards to things that are way closer to, like for me, this really was something that I started, like I finally started thinking about testing of smart contracts from the perspective of unit testing because before that, well, everything needs to go through something that is a real instance, whether it's a sandbox, right, or something like that. And I'm also curious, like, how do you see, like, how self-sufficient do you think that is? Because one might argue that, things like running against real testnet instance or real sandbox instance is also something that further along the pipeline of delivering smart contracts is important to include. But do you think that in this case, AlgoJig is something that essentially, given the fact that it interacts directly with the Go Algorand compiled binary in this case, do you think that this is self-sufficient, or you're also more aligned with the angle of looking at it as more of a, the base layer, the foundation for testing your contracts? But then, of course, well, you got to go through different hoops later on. But or you think that this is something that is entirely self-sufficient?
Yeah, it's definitely an interesting question. It would be nice if I could be convinced that it was like that I could fully trust AlgoJig. But I'm not convinced of that. And so, like, with our we wrote a load of unit tests in this way, and we could be sure that, like, we're exercising every part of the code and things. But then we also, like, we did other kinds of integration style testing. And so, like, long before we published Tinyman v2, we had a testnet, actually, like a public testnet deployment of it, but a stealth version. So we changed all the names of everything. But we had it there, and we were testing that from our Python SDKs and our JavaScript SDKs, and, like, doing some kind of automated tests of running through every scenario through that, just making sure that it acts the same way that we saw in AlgoJig. And as far as I remember, we didn't come across any differences at that point. We did come across some weird errors in AlgoJig at times when we were writing tests, and it would give some strange thing that logically we thought wasn't right. And so then we would look into it and say, oh yeah, okay, we messed up something there about, I don't know, like minimum balance calculations. There was something that was, AlgoJig had a different idea of what was going on than it should have. So there's definitely, like, there's places where bugs can be introduced in there. And so it's not 100% bulletproof. But it would be nice to, I don't know, develop some kind of a test suite for AlgoJig itself, and to be able to, be sure that, to get greater confidence in it. But I think you need testings from multiple angles.
Yeah,
for sure.
Yeah, it's certainly great to hear that. I guess we are on the same page and in regards to looking at this from more of a foundational base for the infrastructure for testing.
And just on the AlgoJig topic, like, for the listeners, I should point out that, like, AlgoJig is a side project, more of a side project than Tealish. Like, I believe that Algorand ecosystem needs something like AlgoJig, and, like, it has absolutely changed the way that we approach contract development. And I know there's a few people like Al who have looked into it and dove into it and been able to use it. But at the same time, there is very, very little documentation about how to use it. And so if you're interested in using it, like, be prepared to read through code, Python code and Go code. It's not really a very developer friendly project at the moment, and it's just about like our resources. We devoted time to it while working on it for our Tinyman V2. At the moment, the spare time that we have is devoted towards a Tealish project. But I would love to be able to devote more time, like as a team, to that project as well at some point in the near future. But yeah, that's just a caveat.
I mean, which makes it even more important for the folks in the ecosystem to take a look into it. Like from my side, I certainly make sure to include all of the links to all of the aforementioned repositories. But this, I think, leads us to one of the sort of final topics on the dive for the Tealish. So we have Tealish, right? A readable language for smart contracts. Amazing keynote given at the Decipher, I think, as highlighted here, it really does change a lot in regards to how smart contracts are approached. Once again, there's things like Beaker, there's things like Pyteal, but those things are building on top of TEAL by, as mentioned already, by introducing a set of primitives within, I would say, general purpose languages. And this intermix could be, something that could be improved essentially. And now we have Tealish, once again, a pure abstraction on top, adds a lot of imperative programming in this regard. Now we have AlgoJig, an offline way, basically unit testing for Algorand smart contracts, something that I believe was attempted before, but not something that was publicly available, right? And you said that this is an approach that's within the internals of the Algorand testing. Now a potential product that can grow and be adopted by the ecosystem. But what's the future roadmap look like for both of those things? You already covered AlgoJig, so I guess for Tealish, right? And another thing, what is the best way to learn Zen of Tealish and for open source enthusiasts to contribute to it?
Yeah, so I mean, the roadmap, a few weeks ago, I published a document on GitHub under the GitHub discussions on the roadmap for Tealish. And it basically covers, I think, from 3 different angles. So there's obviously features to the language. So this includes stuff like the type system that I was talking about, arrays, and some more minor things like about alternative syntax for like constants, like being able to write stuff in hexadecimal where it's more useful, template variables, these kind of things. And then there's the tooling. And so this includes like the compiler and associated tooling. So there's improvements to the error messages that are needed. There's some places where it just gives bizarre errors, which could be much nicer. It's definitely possible to give better errors. There's some places where the compiler is just unnecessarily strict, and so those things can be improved. And then there's some additional tools that I'd like to think about where you could basically have like automated checks on your contract to identify common potential problems in a contract. So basically where you could iterate through all of the different fields that are being checked on another transaction in the group, and then highlight maybe things that maybe should be checked but aren't checked, or some other kinds of like automated semantic analysis of the contracts. And so that involves like building the tools, but also improving the internal language model or the internal program model that is built up as you parse a program. So that's one aspect. That's probably a little bit further in the future. And then one major one then is the documentation side of things. So like it's all well and good to build an open source program or like a library or a project, but with loads of features and it can do fancy stuff if you're the creator of the project. It needs to be, all of this needs to be documented for the other users of the project to be able to use it and also to be able to contribute to the project. So there's multiple different types of documentation needed, and we have the start of something. We have a read the doc site. We have like a description of the features of the language. We have some small examples, some small snippets or recipes, but there needs to be more detailed thing. There needs to be a clearer way of kind of showing how Tealish and the AVM work together and how to read the AVM docs and know how to use Tealish. So that kind of thing. And then, yeah, some tutorials type of stuff for sure. And I really want to have getting started guides coming from different directions. So like you're a developer who's familiar with TEAL. Okay, this is how you get started. I'm going to describe Tealish to you from this perspective. You're a developer who's familiar with Pyteal or Beaker. This is what you need to know, which is quite different. You're a developer who is coming from Solidity or Viper. Okay, you need to get your head around the differences of the AVM and how to write Tealish. Or you're a developer who's coming from no contract writing experience. You're coming from a different starting point. And so I think like a single getting started guide is not going to be useful for every persona. So that's something that we would like to invest some time into, basically developing a great like jumping off point for people coming from different directions.
Just a little comment on that note. I think what can greatly benefit the speed of implementing such documentation for specifically folks. Okay, I came from this background with Pyteal. I want to see the equivalent of this in Tealish. Is implementing equivalents of examples already available in Tealish, Pyteal, supplying it with additional docs, and then running through a language model, even offline, and seeing how, because I think on these tasks for, very sort of, when there's a lot of like logic in the semantics of the documentation, these language models actually do a very good job at generating stuff like this. And then pretty much, I think this could speed up like actually writing the guidelines for, if it already knows the context on the documentation with Tealish, if it knows how the example for this looks like in this language and in this language, then you can just ask it, okay, now, I'm coming from this, write me an example, or like write me a tutorial based on example. And I think that this can really speed up this process for you guys in this case.
Yeah, I think that's super interesting. And like, it's insane that that's like that's a technology that now exists that just didn't exist 6 months ago. And now it's like, yes, as a random like open source project, the technology exists for us, not theoretically, but practically for us to be able to actually train something.
Theoretically, they've been around for a while, like transformers and things like that. It's but like this adoption, the mass adoption, and seeing, not just engineers geeking about this these days, it's puts a lot of things into perspective, I guess.
Yeah, definitely. So that's kind of the roadmap in the relatively near future on Tealish. Obviously, like as new features are added to the AVM, we'll keep up with those and whatever language stuff is needed for those. But yeah, at some point we will definitely switch our focus from features to documentation and more documentation and more documentation. That's probably the most important aspect of this whole thing.
I see. Yeah, perhaps like I know there's also like things like Kappa AI, where you could also or LangChain that can simplify these things. But given the amount of resources and people you have, it feels like the easiest option could be having a dedicated Discord community with a bot that can, in real time, basically answer questions in case when yourself are not available, things like that, and at the same time also act as a feedback loop, right? Because it must be shaped by experience of people using it, and I guess things like these could simplify a lot of building and aggregating feedbacks. But for the sake of time, I know we went over a lot of topics. This is really, I'd say, like for people who like the keynote, this would be the follow-up that they might be interested to listen. But for people who listen to this first, the keynote will be the thing that they might be interested to follow up. That goes on a deep dive there. But before we move on to
that presentation, sorry to cut across. In that presentation, I really thought of it as like, okay, this is the talk that I want to refer people to when they ask like, why Tealish? Or like, where did this, like, why this and not that, or where did this come from, or why is it designed this way? I wanted to really give the kind of the journey and the reasoning behind it. And I will keep referring people back to that. I don't want them to have to listen to me for hours there and hours here. But at the same time, I think if you're going to use a tool, you should know why it exists.
Yeah.
And so you need to know the backstory. And just seeing examples of this is how the thing works, it's not enough. You need to know why it's designed the way it is. And so that was the purpose of that talk. And that's also the purpose, of the purpose of the Zen of Tealish, which you mentioned, which I forgot about. It was an attempt to kind of write down some of the ideas that influenced the design of Tealish. Obviously inspired by the Zen of Python, which is a post from a Python mailing list from, I don't know, 30 something years ago, I guess, and which tried to capture the essence, or I think it was called the way of Python initially, and then it became the Zen of Python. The Zen of Tealish tries to do the same thing, and maybe by those kind of simple statements tell something about our ideas and opinions in designing the language. But I'm not sure that it's going to hold up to scrutiny. So if in some years' time that people want to go through the Zen of Python line by line and see, is this really what Tealish is? We'll see. I hope that some of it does apply, but I'm not sure that all of it will. That we'll stick to that always going forward. But at least it gives our mindset at the time that we started.
The intro to this episode is going to have a nice reference for folks who like the video game Portal and the fans of Valve Inc. It's going to.
I did see this on Twitter. Yeah.
It's going to be a summary. I couldn't fit the whole thing to simulate the GLaDOS voice, but it's going to read a short summary before the introduction to this episode. So if you reach that point, you're probably going to hear this already.
Excellent. Hopefully it resonates with some people.
Well, it certainly will resonate for people who come from like Python native experience, right? It certainly makes a lot of transition into smart contract building easier. In this case, it eases in. It introduces this new paradigm with decentralized application building, but at the same time, the learning curve is way, way, way simpler in this regard.
Yeah.
But before we move on to final question, and from the list of AwesomeAlgo questions that some folks were asking, I will pick the one that weren't basically covered already. I think most of them were essentially already addressed. But before we move on, just out of curiosity as well, like what was you mentioned Barnji from Algorand, right? Who's actively contributing to it. So I suppose this is an indication of, interest and support from folks at Algorand to languages like Tealish. But what was like the sort of overall response in regards to it? Because I believe, of course, there might be engineers from their side, right, who already spent a lot of effort into building Pyteal from ground up and things like Beaker, and it's also, there could also be some sort of like creator bias, right? But at the same time, I feel like there's certainly a space for both languages to coexist and serve different purposes in different contexts. I was curious, like, what was the overall like sort of response? Because I know from the community side, there's certainly prominent projects like NFD, for example, who are also very keen on supporting Tealish and things like that. But what was the overall sort of response to like initial introduction from Algorand?
Overall, it was extremely positive. Some people I had talked to, so before that's Decipher session, some people I hadn't. But generally so like Barnji, for example, I've been sending him ideas about this for probably like since that first version of a Tealish kind of thing, or maybe even before that. So we've been chatting on Discord for years, and I was constantly we were talking about ideas around things. And so he probably wasn't very surprised when I told him that, okay, I've done it. I've made a compiler for this thing, and got his opinion about it. And so like I got the opinion from the DevRel team relatively early on, and they were pretty interested and excited about it. And then, I talked to some people from the foundation, and because like John Woods had this drive about improving the developer experience in Algorand, and he talked about languages and tools. And I said, okay, I need to contact John and tell him that like, this is something that I'm working on. We are building this at Tinyman. We are building this for a real need. We've been thinking about this problem for nearly 2 years. So I wanted to kind of show him what we were building. And he was interested in the project for sure. And I talked to a few other people at Inc, like Anne and JJ. I mean, I definitely expected some kind of pushback because like Pyteal and Beaker are the way that Inc is pushing things, and they put a lot of effort into it. And like, I absolutely don't want to diminish any of the effort that they've done on that. And I think like they've really put a lot of effort into it, and they've pushed the Pyteal thing to beyond the limits, and they've made it like workable for people for quite a while. Like Beaker is a big improvement, and like it helps people to structure their applications. And there's definitely a lot of value in that. But so I thought there could be some pushback against something that's doing something different, but they've all been very supportive of the idea. And so I was quite happy with the response. And as you say, from the community, so there's quite a few projects who were interested and doing some stuff with it. Some people have a long list of feature requests before they will start with it, which gives me some ideas about things that are needed, which I hadn't thought about. Some people have dove in and actually have written contracts, and I don't want to name any names yet because they mightn't have. I don't think anyone have made them public yet. But there's projects from a few prominent projects. Some contracts from a few prominent projects that are written in Tealish at this stage. And so once they go public, they'll go on the website, and there'll be nice references for other people. For a lot of them, they were kind of inspired by the Tinyman V2 contracts. So when we published them, they said, okay, like I read your contracts, it was readable. I didn't know about Tealish before, but I read your contracts and I understood what was going on. So I want to try out writing something in Tealish. That's exactly what we were aiming for. So the community response has been good. And and also from Inc and Foundation. We'll see if like Tealish gets integrated with AlgoKit. I'm still unsure about the direction that AlgoKit is going. And
I mean, I guess this will be like the task itself is very trivial, right? It's a matter of setting up a scaffolding project. I guess it's something that could be addressed once the kit itself is solidified and in like the first sort of public release stage. But I'm sure like the integration itself is going to be easy.
Yeah, and like for the kit, like as part of that, they want to give a single direction on how, so developers don't need to make decisions about how they should do things or research different options. There's a kind of a standard path in terms of the tooling and things. So it makes sense for them to be sticking with one specific language to start with and one framework and things. But I would be hopeful that Tealish can be an option in there and maybe be the preferred option at some point in the future. It's definitely the aim of Tealish.
The fact that they have the language as a selection option when you deploy a scaffolding project with AlgoKit is probably indicative of the fact that they're considering different combinations and features. So
definitely,
I'm very hopeful in this as well.
Yeah, and like right now, maybe Tealish is most accessible to people who are already have a bit of experience with writing contracts in Algorand. But really the aim is that it would be the most accessible language for any developers coming to Algorand. So prior knowledge of TEAL should not be necessary for Tealish. You should, as a beginner on Algorand, you should be like Tealish should be the one that appeals to you most and is the most accessible.
Kind
so
of like with
we
Solidity,
obviously
right?
have a way to go to get there. Yeah, like Solidity, but hopefully much more accessible.
Oh yeah, I mean certainly not in that sense, but like in regards to that, AVM also had their own bytecode-like language in the early days, and then they came up after a lot of different iterations. They came out with Solidity, which ended up being like the standard for EVM smart contracts. But yeah, like Algorand, the fact that the thing with Algorand is, I guess the community should avoid any signs of anything that could say that, okay, this is probably something that may turn into like a premature standardization or whatever, like it's an early community, right? Started blooming in 2019. We should always iterate, we should always evolve things that adapts to the needs of developers. So I think Tealish is a step towards a very good direction. So
and the idea is to introduce a choice and a possibility and to see where that goes. Like I think it's far too early to be standardizing stuff. Yes, like having a standard learning path is a good idea for newcomers, but we shouldn't be saying like, no, okay, we are done, we have the languages we need, we have the frameworks. There's other stuff that has been standardized already that I really believe shouldn't be standardized yet. Like we need to allow time for experimenting. The pace of development is also quite slow in like smart contracts compared to some other like traditional software engineering stuff, because it's a slow process to write and to test and to audit and to launch protocols. And so we don't have that many use cases of things doing stuff on mainnet. So we shouldn't be standardizing anything at all yet. Like the protocol itself, yes, it has its own specification and that needs to be extremely strict and well communicated. But anything other than that, I think it's far too early to be standardizing. So we need to allow for experimentation and people to find different ways to improve different aspects without worrying about, am I breaking this standard or this standard?
Would you say it's also an answer that you would have given if I asked you what's the main issue with ABI?
Yes.
Okay. So whoever asked this first question there, I think you got the answer as well.
Yeah. That's my main issue with the ABI. It was standardized before it should have been standardized. And it co-opted too much stuff from Ethereum, which didn't really apply to Algorand, but for some reason was included in the standard. And it was unnecessary to create a standard at that time. It's still unnecessary now. Like I think guidelines for a good structure for your application is a good thing, but there's really no reason to have a standard for that stuff. This whole, like the idea that the ABI is necessary for interoperability and composability between contracts, that's nonsense. Like absolutely nonsense. It is extreme. Like Tinyman is not ABI compatible not because I just don't like the ABI, but because we wanted to do stuff that the ABI doesn't allow for, because it was standardized too early and it didn't think of all possible scenarios. So we said, okay, none of it is, we're not just going to pretend that it's ABI compatible. It's just not. But it doesn't mean it's any less composable than any other protocol. It's actually much easier to interact with than others. The application arguments are very, very simple. And as long as there's good documentation, which you need for every single protocol, no matter whether you have a spec or not, you need a documentation.
I must say that like within the context of like if you live completely in the world of tooling such as Beaker and things like that, and like pair it with tools like Diapflow or whatever, it does make sense in certain contexts. But like if you look at it from a different angle and look at the niche of the amount of people available for building stuff that will directly interact with your smart contracts, I'm pretty sure it's not going to be a large amount of people. And if you also look at the amount of let's say, retail users, right, who would have a need to directly call your application.
Yeah.
I don't think it's a large amount either.
No.
The fact that they thought about standardizing this and coming out with some set of, like, I always think of it as a Swagger for smart contracts, basically. But well, I mean, there certainly needs to be a lot of use cases for people who actually benefit from it. And I would say certainly agree with your point here.
And certainly, like with Swagger, like, yes, it describes the interface to your protocol, or to your REST-like API, but it doesn't replace the need for actual documentation of how the API works and like what it does. You still often need to use an SDK to interact with an API, even though it has a Swagger documentation. Just using a generic open API client is not enough.
Yeah, exactly.
And so we've seen this many times over the years with RPC style frameworks and like automated client generation for these things. Pico, which I talked about at the very start, like that's an example of that. There's an automated, like the JavaScript client is automatically generated from the description that is provided by the Python code. And it's all very minimal in things. And it's great for like small toy stuff, which is what I was using it to build. But it's not something that you use to build
a decentralized exchange.
Yeah, or like many other applications, because like all of the advantages it provides they're not all that useful. Like the automated generated client, yeah, okay, but making the HTTP request is not the hard part. Just like making the application calls to the transactions, whether they're inner or outer transactions, that's not the hard part. It's doing the calculations offline that is the hard part. And that's what contracts, the way that we design them to verify something that has been computed offline. That's the ideal way to structure an application. So there's a lot of stuff that has to happen offline, which is usually implemented in the SDKs, but you can't describe. So you always need a hand-built SDK for your protocol if it's doing anything interesting. And so that's why, like, actually that bit of doing the application call, that becomes like 10% of the work. 90% is the application specific stuff. So then it's not saving you all that much.
Sorry, like we went on a tangent a bit with ABI, a lot of ranting with ABI, but not to just completely talk about negatives of it. One additional thing I wanted to highlight that, at least in my case, I found very useful in regards to deployment to things where you have dependency on JavaScript or TypeScript, is this little experimental addition on top of Beaker called Beaker TS. Maintained by Barnji, and that thing is very awesome for cases when you have a web platform. Basically, you have a client written in Beaker, and you basically don't have time, or you don't want to spend time building an abstraction layer on top that can interact with it. So that's where I guess ABI gets handy, so that you can define a method, and you don't have to deal a lot with building and extracting low-level methods from Algo SDK to interact with it. But if there was a way to take that aspect without introducing a lot of standardization into the contract level, I think that would have been amazing. And I think this is actually that could have potential if, in the future there would be a plugin ecosystem growing for Tealish, because I could certainly imagine something like that for Tealish that doesn't necessarily involve ABI like standardization in this regard, but allows you to quickly deploy a JavaScript client based on your Tealish code or something like that.
Yeah, absolutely. So like that's part of the intention, that like a contract, you should be able to introspect a contract or inspect a contract from a external tool to be able to extract information from it, so that you can produce this like JSON, which you can then use to plug into a TypeScript or Python or some other kind of client to be able to create a a simple interface to that contract. I think that is definitely still valuable. There's just no reason that it has to be the ABI as it's spec today, or no reason why that thing has to be the same as what's used on Beaker or some other language that might exist for the AVM. They don't need to be the same. So if we allow for the flexibility, then we allow for each to be tailored and specifically for the way that the contracts are designed in that language. So yeah, my hope is we'll definitely end up with something that's as nice and useful as that, just without the constraints and the baggage of the ABI spec.
And for the listeners out there, please don't take our rants about the current tools and things like that in good system too close to heart. If you were to compare this with the experience you would get, let's say 2.5 years ago, it's night and day. Like, don't feel discouraged by listening to this. Like, we're really complaining about things that, you couldn't have even thought about such use cases a couple of years ago. So like the dev ecosystem, the stuff that Foundation, Nink are doing, the stuff that Fergal is working on with Tealish, this is all are significantly simplifying smart contract development. But nothing is perfect. Things need to evolve. Things need to improve eventually. So certainly, we're not ranting about state of the ecosystem a couple of years ago. I would be very grateful, actually, to start building today rather than starting a couple of years ago on this, because it would allow me to do a lot more, actually. But I guess
I'm always just looking for ways to improve these things, and
exactly.
If there's a standard, I want to ask, why does the standard exist, and what alternatives have been considered? And make sure that there is, that is really the optimal way to be going. But I think it is useful to have these things as guidelines, and it's useful that all that work was put there in the first place. And people continue to discuss this on a daily basis on Discord and GitHub, and all of those discussions kind of add up to our learning as a community, and they'll just propel us further and allow us to make better and better development tools.
I guess that leads us to the final question of the episode that I usually ask to all of the guests, and I think in this context it's even more meaningful to ask it. But what advice would you give to aspiring software engineers who want to try their hands on blockchain developments on Algorand, or just generally get into Web3 space?
Okay, so I'd love to say that, if you're an early developer, but you're interested in crypto and blockchain, so you should dive straight into contract development and things. It's great fun and it's easy. But I wouldn't. I don't think that's a good path. I think before you get into this space, you need to make sure that you're a really solid engineer and you have experience in one language really well, and you've experience with some other languages. Make sure you're a well-rounded software engineer, have experience on the front end and back end. You really need to have a full stack understanding to work in this Web3 or decentralized protocols and Web3 kind of space, because you there's so much. Even if you're writing contracts, or you're writing front end, or you're writing the back end parts of these, you need to know how all of it fits together, and you're really going to struggle with that if you don't have the fundamentals down. So make sure you're a really solid engineer before diving into this stuff. Otherwise, you're just going to be massively frustrated. But if you are at that point, then the absolute best way to learn things is just to build. So get building. Don't dive straight into contracts, but build using the SDKs, building transactions on the Python side, on JavaScript, build some interfaces, interface with the wallets, integrate Connect and all those kinds of things, and just understand the flows of information, the data structures. Dive into Go Algorand source code. That place is a gold mine. There is so much stuff in there that It's not documented elsewhere, but it's in there in the code, and you'll learn so much about how this system works. There's so many different aspects and layers to it. Like that's all those things is how you learn in this space and how you develop. But you need to come in having lots of curiosity and questions and wanting to build something. And then once you have some idea of those things, then jump into smart contract development. But don't dive into smart contract development before you've done those things. Otherwise, it's just not going to make any sense.
And you'll probably just get disappointed or frustrated too quickly with this.
Yeah,
so.
Definitely.
Well, with that, Fergal, I can agree more with that particular answer. I think we had an amazing conversation. I'm sorry we went a bit longer than we initially planned, but it's
apologies to the listeners if you get to this point.
But regardless, I think Tealish, I was really happy to hear that there's a generally very good response, both from the community and from the Algorand side. I would absolutely love to see how the project evolves. You have my undying support with it. And with
Thank
that, thanks a lot for coming to the podcast, and for the listeners out there who made it that long. Thank you for staying with us. Stay tuned for some more updates for the next set of guests.
Thank you so much.